we're going to get into some harder problems on solving equations, and what you're going to find in these problems is that you can't use any trig identities to help you, and you're kind of stuck at the beginning. And so when you see that you have solve sine theta minus cosine theta equals 1, there's nothing that you can do in terms of substituting in. There's no algebra that you can do. So because you are stuck, you have no alternatives. The only thing that you really can do is to square both sides in order to eventually use a trig identity. So one thing that you have to know when you square both sides is that you have to check for extra answers, called extraneous answers. So you have to check once you get to the end. By squaring both sides, it can produce answers that don't satisfy the original equation. So I'm going to look at this first one. I get stuck. I have to square. I want to be smart about solving. On this one, generally you want to separate the sine and the cosine. That's not always the case, and you can do this one without, just because of the way it shakes down. But I think the good approach would be to separate the two, so then you have sines on one side, cosines on the other side, and then you can do a trig identity to help you solve for it. So what I want to do first is to get the sines and cosines separated, and then I want to square both sides. When you square both sides, I want to go ahead and remember that it's cosine theta plus 1. When I square that right side, I want to make sure I FOIL. I have 4 multiplications through. So this becomes if you wrote this as cosine theta plus 1 quantity squared, and then you just said, oh, well, that's going to equal cosine squared theta plus 1 because you're going to distribute that power through, that is not true. You don't want to do that. If you did do that, everything after this point is going to be wrong. And if I do see this on the test, I'm just going to put a big X through it and not even look at the work after it. So you don't want to do that algebra mistake. Going back to here, I now notice that I have sines on the left side, cosines on the right. I want to change it all to cosines, get it on one side, and then solve. And then check my answers. So at this point, it's all pretty much the same. 1 minus cosine squared theta by the Pythagorean identity. Getting everything on one side, it's going to be, let's see, subtracting 1 and adding cosine squared theta. Subtracting 1, adding cosine squared theta. Zero, 2 cosine squared theta plus 2 cosine theta minus or plus 0, which would be just that. At this point, if you wanted to, you could factor out a 2 cosine theta. And set both of those equal to 0. Now, the good news on this one is that it's dealing with just zeros and ones, so all I'm really doing is looking at my cosine graph and picking off the numbers. So when I draw the cosine graph, (360 degrees). So where it's 0 and where it's -1 are going to be those points, which means that my potential answers are going to be 90, 180, and 270. Now, I have to remember to check these answers because of that squaring business. So at this point, what I want to do is make an extra table to keep nice and organized in my work. You don't want to just do this as scratch off to the side. You want to stay organized, and it makes sense to put it in a table. So I'm going to have 90, 180, and 270 for my angle. And what I want to do on the top is going to be to use the original equation before I square. So it's sine theta minus cosine theta. And the question is, does it equal 1? Now, I have a sine and a cosine. This is my cosine graph. I already have that, but I should also draw the sine graph to make sure I can get numbers off of theirs as well. All right. I like working with just the sine and the cosine separately because I'm just looking at the same graph. So when I look at sine theta and go to 90, I know that that's going to equal 1. So this is going to be 1. 180 is going to be 0, and 270 is going to be negative 1. Pull down the negative signs. Cosine theta, I'm going to the other one. Cosine of 90 degrees is going to be 0, negative 1. Be very careful with the minus negative. And then at 270, it's equal to 0. If you do this nice and big, you can see where you're going here. 1, 1, and negative 1. These two work, and this one does not work. So therefore, your answer at the very end is going to be theta is going to equal 90 degrees and 180 degrees. Whenever you square both sides, make sure you put up in a nice table and check your answers. You will get points off if you don't check your answers. The other type of problem that you're going to run into is a problem like number 26. And the problem number 26 has some square roots in it. Now, when you have square roots in the question, what you're going to want to do is actually try to eliminate the square roots. You can't do any identities, no real algebra to help you out, so you're stuck, you've got to square. It's the same type of problem. But I just want to show you that when you have square roots, you want to eliminate those square roots when you square. Therefore, on this one, what I would do is I would separate and get the square roots together. And then what you could do is you could square both sides at this point, or you could actually square factor out a square root 3 and then square both sides. And if you square both sides at this point, you're just going to have to square the radical 3 and then square this binomial at the same time. All right, so you could square at this point, you could square at this point, whichever way you prefer is, I'm just giving you a couple options there. All right, my main point on this one is separate it down into radicals and non-radicals and then square and do the same process. I'm not going to go through how to do this. The next type of problem that we're going to have is going to be a calculator problem. I'm going to put calculator problems on your take-home test as well as on your in-class test. So you're definitely going to want to know how to do it on your calculator. You need to know how to do this in AP Calculus. So I want to make sure that I hit this and that you're comfortable with it. I want to go through and look at number 52. And number 52 says that you have 4 sine theta equals 3 minus 2 cosine squared theta, and we want to find answers between 0 and 360 degrees, and including, let's say, 0 and 360. And so you want to solve this. Now, I'm going to show you 2 ways of solving this, and again, you can pick which way makes sense to you. One way to solve it is to say, so the first way is to say that I want to graph this in y sub 1, and I want to graph this in y sub 2, and then I want to show where they intersect. The second way that I can show this is going to be where I put everything on one side of the equation and then just see where that equation goes through my x-axis, because your y is equal to 0. So I would need to put 0 on one side, 3 minus 2 cosine squared theta minus 4 sine theta. And then I have one equation, and then I would want to find out what my zeros are. Now, one thing that you have to remember when you're graphing is when you have a 2 cosine squared theta, you have to write it in your calculator correctly. So it's 2 and then parentheses cosine theta, end of parentheses squared. So you're squaring only the cosine theta. Some calculators are different, but I always like to put parentheses here and then make sure that I'm squaring only the cosine theta. All right, so we're going to go ahead and put this in then. And we'll just do the first method, and then we'll go to the second method. So first thing I want to do before I even start is check mode. Is your mode in degree mode? Yes. If it is in radian mode, you can do everything right and get the wrong answer. So that's an important check. I also want to go to the windows, and on the windows, the x is built right into the 0 and 360. So I'm going to say -10 and 400 to give me some space on the side so I can see what's going on at 0 and 360. And then your y min and y max, that's a little bit of a guess. You want to see the y equals 0, and so what I did, I just put in -10 and 10, hopefully cover what I want. I can easily adjust that if there's a mistake. Then I go to the y equals, and I'm going to just plug in my 2 sides, this is y1 and that y2. So 4 sine x, and the second one, 3 minus 2 parentheses cosine x. Notice there are 2 parentheses on this calculator, one to finish the x, one to finish the cosine, and now I want to square what's before it. So I'm squaring the cosine only in parentheses. Those are my 2 equations. I now want to graph them. I already got the window correct, so I hit graph, and hopefully I'm going to show intersections of the 2 because that's where my solutions are going to be. And so I have something like this. And now I want to see what those intersections are. If you don't get that, then I can help you with your calculator later. To find those intersections, again, it's second calculate and intersect, number 5. So second calculate, intersect number 5, and then you're just following the command. First curve, enter. Second curve, enter. And then it says guess. And then your guess is just move it to the location of where you think you want to find that intersection. Doesn't have to be exactly on it, but when you hit enter, I got 162.97. 162.97. Then I'm going to do it again just for, because I need to get the next one. So again, second, calculate, intersect, which is number 5. And then, again, you're just going to follow first curve, second curve, and then guess. So I'll just hit enter. Second curve jumps down to the second curve automatically. Hit enter. My guess, and I hit enter, and so that's going to be 17.03. You have one more intersection, and again, the question is that before or after 360? If I trace this, you can see that at 360 degrees, you didn't get to the intersection yet, and so it's going to be after that intersection. But if you wanted to calculate it again very quickly, second, calculate, intersect number 5, first curve, yes, second curve, yes. Guess I'm right on it anyway, and that's going to be 377, so that doesn't matter. So these are your 2 answers that you're going to get. That's one method in doing it. If you like that, stick with it and get your answers. You could get an equation that's equal to 0, though. If you have an equation equal to 0, then you're going to put everything into y equals. So what I'll do is just clear that out and go down to here and put in minus 4 sine theta for sine x. And now I want to find out where this equation, your y sub 2, intersects with the x-axis, because that's where your y is equal to 0. So to find this, I'm going to again graph it. And again, my question is, where is it crossing the x-axis? To show this, or to have your calculator calculate it, I'm going to hit second calculate and then go to 0 instead of intersect. 0 means where y is equal to 0. 0 is a 2. And now you're following these different commands. Left bound means left side of the intersection. So I'm going to hit enter. Right bound means right side of the intersection. Enter. Guess you go in between, and you're going to see that's that 162.97, which is what we had before. Right? And you could do the same exact thing on this other intersection. And so pick a method. Now, if your equation is set to 0, you'd have to do this method, or you could bring a term over on the left side and do the intersection of the two. It's up to you. So get comfortable with one method. You definitely have to know this for the test. I am definitely putting them on the test. Okay, this is important. Remember, check your mode first. Set your window. Plug them in correctly. I'll have students coming up to me on the test saying my calculator isn't working right. Well, it's because you did something wrong. So be careful on how you put it in. I'm not going to answer questions on your calculator when it's test day.